Hi guys, sorry I got cut off there. So we've listed each of our unique factors. We have x minus 2, x plus 3, x plus 5. So x minus 2, x plus 3, x plus 5. And now we go through each individual line and say what is the greatest number of times each one of these is expressed. So if we look at x plus 2, that only appears in this bottom line. It only appears to a power of 1. So we just have 1 x minus 2. Next we have x minus 3. And that appears in both of our polynomials, but both times it only appears to a power of 1. So which is the greatest exponent? We keep that. Well, it's still only to a power of 1, so we have x plus 3. And now lastly, we have x minus 5. So we've included x minus 5. It's only to a power of 1 as well, so we only include it one time. And so our least common multiple between these two polynomials is x minus 2 times x plus 3 times x plus 5. On to the top of the next page. Recall that to add fractions with unlike denominators, you need to rename the fraction using the least common multiple of the denominators known as the least common denominator. That's just saying in order to add fractions with unlike denominators, you have to figure out what your least common denominator is and adjust each fraction so that it has a common denominator of that. So key concepts. Use the following steps to add rational expressions with unlike denominators. Step 1, find out what your least common denominator is. That's good. Step 2, change each rational expression into an equivalent expression, meaning same expression, with the least common denominator as the denominator. So manipulate your equations so that you have the same denominator. Step 3, add just as with a rational expression with the like denominators, simplify if necessary. So this will make more sense when we do example 3. All right, so example 3. We're told to add a plus 1 over a to a minus 3 over 3a. So again, you'll notice you cannot add these two fractions as is because you have unlike denominators. You have a and you have 3a. So that means we need to find out our least common multiple or our least common denominator, same thing. Least common denominator, which means least common multiple, between a and 3a. So what are our factors of a? Just a. What are our factors of 3a? 3 times a. Now remember, to find our least common multiple, we list each unique term. We don't repeat any terms, we only add exponents. So we're looking for every unique term that's being multiplied together. In this case, we only have 2, we have 3, and we have a. Those are our only unique factors. And now we go through and we say, what is the highest exponential value of any of these factors in a single line? And then we'll take that into our greatest or our least common denominator. So if we're looking at our 3 first, 3 only appears in this bottom line, and it appears to a power of 1. So that's our greatest exponential value for 3 is just 3 to the first power, which is just 3. Now we're going to do the same thing here. We have an a in our top line, an a in our bottom line. We don't combine them to come up with an exponential value. We just look at them individually and say, in our top line we have a to the first, and in our bottom line we have a to the first. What is our greatest exponential value between these two, not combining these two, but between these two? Well, it's a to the first. Again, if this had been 3a squared, we would have said, okay, in our top line we have 3a to the first, but in our bottom line we have 3a squared. Then therefore a squared would be our highest exponential value, but both of them are the same. So our least common denominator is 3a. So now we have to ask ourselves, what do we have to do to both our top, or not our top and bottom expressions, our left and our right expressions to ensure both of them have a common denominator of 3a? Well, luckily, this one already has it. I don't have to do anything to manipulate my right equation to get it to have a denominator of 3a because it's already there. But what I do have to do is manipulate my left one so that it has a denominator of 3a as compared to just a. Well, a times what is 3a? A times 3. So I'm going to have to multiply this denominator by 3 in order to get 3a. So I'm going to put that over here actually. But can I just multiply it by 3 in my denominator position? No, because that will unproportionately or disproportionately change my equation. I have to keep it balanced. So what I do to the top, I have to do to, or what I do to the bottom, I guess, I have to do to the top. So since I have to multiply my denominator of a by 3 to get it to 3a, that means I have to also multiply my numerator by 3, because 3 over 3 is 1. I'm essentially multiplying my entire problem by 1. I'm not changing the value of it. I'm just inflating it in order to get to this correct expression. So after I multiply my numerator and denominator of my left side problem by 3, I'm going to end up with 3a plus 3 over 3a plus a minus 3 over 3a. I have common denominator, so now I can add them up. 3a plus 3 plus a minus 3 over 3a. Bring your like terms together. So I have 3a plus a is 4a. Now I have 3 plus a negative 3, which is just going to cancel out. 3 plus negative 3 is 0. And so I'm done there. Rewrite my denominator. And my simplest problem here so far is 4a over 3a. But now I have to ask myself, can something else cancel out? Am I at my fully reduced form? I am not if I still have common factors that can be divided out. In this case, my a's can actually get canceled out or divided out, and I'm left with 4 over 3. And now I've simplified this fraction to as low as it can go. Just like a conga line, or a, what is that called when you're at a party? Do y'all know what I'm talking about? When you have to go underneath the bamboo pole? Man, I do not remember what that's called. Anyways, that's what I'm talking about. La 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 la. Teaching without students makes you feel crazy. All right, example 4. So we did monomials. The a plus 3a was a monomial. Now we're going to look at polynomials. So for example 4, we're still going to be adding rational expressions, but they're going to have unlike denominators. And this time it's going to be a polynomial that I have to come up with the least common denominator of. So we have the expression y minus 2 over y squared plus 4y plus 4 is being added to y minus 2 over the expression y plus 2. So step 1 is always going to be to factor when it comes to finding your least common multiple / least common denominator. They're the same thing. So if I have the expression y squared plus 4y plus 4, what are my factors of 4? That's sum to 4, easy, 2 and 2. So I have y plus 2, y plus 2. And now down here, I have the polynomial y plus 2. What are my factors of that? It's just a single y plus 2, right? Factors are multiplication, so this whole thing is just being multiplied by 1, if you will. 1 times y plus 2 is y plus 2. I don't have to include 1 as a factor, because everything has that. And so now, when it comes to finding out what my least common denominator is, I look at all of my unique terms. Well, in this case, my unique terms are just y plus 2. And now I have to go back through and state what is my highest exponential value of it, given each particular polynomial. So in my first one, I have y plus 2 times y plus 2. So here, it's y plus 2 squared. In my second polynomial, I just have y plus 2 raised to the first, so just to a power of 1. For my least common multiple or denominator, I assume the exponent that's bigger. I don't combine them again. I'm just looking and comparing. Option 1 to option 2, always take the bigger one. That's option 1. So my least common denominator is y plus 2 squared. So that's what I'm going to have to get both of these denominators to be. And again, luckily, this one is already y plus 2 squared. So I'm going to rewrite. I have y minus 2 And then if I factor the denominator, I get y plus 2 squared. I get y plus 2 times y plus 2. And now my goal is going to be to get my second polynomial to have a denominator of y plus 2 squared, or y plus 2, y plus 2. But I currently have y minus 2 over y plus 2. So what do I have to do to my denominator to get it to be y plus 2 times y plus 2? Well, I'm going to have to multiply it by y plus 2. But what I do to the bottom, I have to do the exact same thing to the top. That way it's the same as multiplying it by 1, and therefore not changing my problem. So we're going to rewrite it now. I have y minus 2 over y plus 2 squared, just because y plus 2 times y plus 2 is y plus 2 squared, plus, now this one has a denominator of y plus 2 times y plus 2, so y plus 2 squared. But now we have to draw back on your rules of factoring. If we have y minus 2 times y plus 2, so if we have a plus b, my dog's right there, a minus b, these factors produce what? They're the factors of a squared minus b squared, right? So what is my y value? My y value is, not my y value. Sorry, my dog is wanting to learn math right now. Okay, what is my a value and my second expression? Well, it's y. So I need to square my y value in order to have my difference of perfect squares. So it's going to be y squared minus b. So what's b? B is 2. So what's b squared? If b is 2, 2 squared is 4. That is how we come up with the numerator of our second polynomial. So again, one more time. We had y minus 2 times y plus 2. Whoops. Y plus 2. Y minus 2 times y plus 2 is the same thing as a plus b times a minus b, which is the same thing as the difference of perfect squares. When that's the case, you take your a value, you square it, you take your b value, you square it, all with subtraction in the middle. So my a value was y, my b value was 2, so 2 squared is 4. And so this is my simplified expression. And now I can actually do my addition or subtraction. So everything is under the common denominator of y plus 2 squared. And now I have the expression y minus 2 plus y squared minus 4. Do I have any like terms? Yes, I have 2 and I have 4. So now this is going to become, in order of descending, y squared plus y plus negative 2 plus negative 4 is negative 6, so minus 6 over y plus 2 squared. But I'm not quite done yet. Now I want to factor my numerator to see if I can simplify it any further. What are my factors of negative 6 that sum to a positive 1? That's going to be 3 and negative 2. So after I factor this, I'm going to get y plus 3 times y minus 2. Yeah, all over y plus 2 squared. And you'll notice, unfortunately, I have nothing to cancel out. I have a y plus 2 in the denominator, but y minus 2 in the numerator. So unfortunately, or fortunately, up to you, this is as simplified as it gets, and we're finished at this step or this step. Very good. All right, one last example. That is all about subtracting. And hint, it's very, very similar.